Okay, welcome back, and today we are going to discuss multiplication matrices. Okay, so we're going to start with uh, the basic type of multiplication, which is a scalar multiplication. So scalar multiplication means we're going to multiply a matrix by some real number, which we call a scalar. Okay, so again, in matrix multiplication or matrix algebra, we call real numbers scalars. So scalar multiplication, for example, in this case, we're going to multiply this matrix A, which is defined by this, by -5. So that means that we're going to multiply every element in A by -5. So we're going to multiply 3 by -5, 4 by -5, 0 by -5, and -1 by -5, as I show here. And so that means that the resulting matrix is going to be this matrix right here, okay, which we may call matrix B, let's say. So that is one way to do matrix multiplication, or to do multiplication with matrices, is this what we call scalar multiplication. Now, what if we want to multiply one matrix by another matrix? Well, let's use the example with the sofa and chairs with the three models. So let's say this uh, matrix W represents the number of sets at three different um, outlets, let's say. So we have, let's say I think it's what are they? I forget what the other one. I know this one's Chicago and San Francisco. I forget what this one is, but let's say these are three different locations, and these are the three different models. So here this column is A, B, model B, and this is model C, and then this row represents one geographic region. This represents Chicago, and this represents San Francisco. New York, New York. There it is. Yep. So this represents New York. Okay. So we can easily see that this is the number of sets that are in Chicago of model A. This is the number of sets that are in, or excuse me, not Chicago, New York. This is the number of sets in Chicago of model A, and this is the number of sets in San Francisco for model A, and so on and so forth. Okay, so this represents the number of sets for each model at each location. Okay, now, what if we're selling each model for a different price? So model A is going to be sold at $1,000. Model B is sold at $1,200, and Model C is sold for $1,400. Okay, so the way we would figure out the total value in New York, let's say, is we would obviously take the number of sets of Model A and multiply by 1,000. Then we'd take the number of sets of Model B and multiply by 1,200. And we'd take the number of sets of Model C and multiply by 1,400, right? And these are the totals we get for those. And we add those up and we get a total value for New York City of 22,600. Okay. So notice that we are taking the 1073, so 1073, we're multiplying it by the 1,000, then the 1,200, and the 1,400, adding them up to get a total value. Okay? So now, respectively or similarly, in the same way, we can find that the sets in Chicago have a total value of this number, and San Francisco has a total value of this number. So we're just taking the number of sets respective by the price and adding them up to get a total value. So let the prices, the different prices, be matrix P. Let's call it, it's a column vector. So we have a column vector, a 1 by 3 matrix, okay, or a column matrix. And then let's also define the matrix of the final values, the total values at each location. New York, Chicago, and San Francisco, and we'll say the V. Okay, so what's going on here? Well, based on what we just seen, we can look at this as a matrix multiplication. So W times P, so here's W times P, is equal to 22,600, 24,200, and 16,400. But how did we get that? Well, we took this row and multiplied it by the column, and that gave us this one, and added those up. So we took this times this plus this times this plus this times this. So we're multiplying and then going across the row and down the column. And then what do? We go to the next row. We go across the row and down the column to get this one. And then the last one was we go across the row and down the column to get this one. So we're multiplying the products of each one and then adding them together. So this times this plus this times this plus this times this. And then this times this plus this times this plus this times this, and so on and so forth. And that's how we get this one. So now, how do we multiply matrices? Well, this is exactly the way we do it. So if we let A be an m by n matrix, and we let B be an n by k matrix, notice that the number of columns in matrix A is the same as the number of rows in matrix B. That is a requirement. If those are not the same, we cannot do matrix multiplication. Okay, there is no solution. To find the element in the ith row and jth column of the product matrix AB, we multiply each element in the ith row of A by the corresponding element in the jth column of B, and then add those products, just exactly like we just did. The product matrix AB is going to be an M by K matrix. Notice it's going to be an M by K matrix. So the product AB of two matrices, A and B, can be found only if the number of columns of A is the same as the number of columns, or excuse me, the number of rows in B. And that's exactly what this is saying. Okay. Notice that this is the same as this. The number of columns in matrix A is the same as the number of rows in matrix B. And that should always be the case. If it's not the case, there is no solution. Cannot do it. So let's look at these two. So if we want to calculate the product AB, well, we would first go with the first column and the first row with the first column. That's going to give us the number that goes into the first row, first column, of the first cell, if you will, the first element. And the way we do these, we always go across. This is 1, 2, 3, 4. We always go in a zigzag. So it's across the row and then down. So we always go across the rows and we go from the top row down. Okay. So we're going to do this row times with this column. So we're going to go 3 times 1 plus 4 times -2. So we're going to go 3 times 1, which is 3, plus 4 times -2, which is -8. And so 3 plus a -8 is a -5. So the element is going to be a -5. Okay. And so that's what we get here, -5. So first row, first column. And then it goes first row, second column. So we go to the next column. So we always start with the first row, and we always, what's the word I'm looking for? We always cycle through the columns of the second matrix. And then once we do the last column, then we go to the next row in the first matrix. That's the algorithm here. Okay, so now we're going to jump to the second row here, and now we're going to get this. So this is going to be element 2. Okay, so 3 times -2 is -6. 4 times -4 is -16. -16 plus -6 is a -22. Okay, And then now we're done with the second row. Now we're going to go, or the second column. Now we're going to go to the second row, first column, to get the third one. So that's what we're going to do here. So 1 times 1 is 1. 2 times -2 is -4. 1 plus -4 is -3. Okay. And then last but not least, we go second row, second column to get the fourth element of our product matrix. And so it's going to be 1 times -2 is -2. 2 times -4 is -8. So that's going to be -10. Okay. So when we multiply these two matrices, we get another 2 by 2 matrix. And these are the elements: 5, -22, -3, -10. Okay. And notice that it is a 2 by 2 matrix because we have 2 columns, right? Two columns here, 2 rows here. Okay, so the product of a 2 by 2 matrix and a 2 by 2 matrix is another 2 by 2 matrix, which should make sense because these two cancel. The inside ones are the same, they cancel, and what's left over is the outside ones, which is going to be a 2 by 2 matrix. Now what about this one here? We've got A and B, so we want to do compute each of A, B, and then BA if possible. Okay, so let's do AB. Well, let's check to make sure we can do that. So this is a 2 by 3 matrix. This is a 2 by 2 matrix. Well, the number of columns is 3, right? And the number of rows is 2. Can we do A times B in this case? And the answer is no, it's not possible because the number of columns here is not the same as the number of rows here. So that is not going to work. Okay, AB does not exist because the number of columns of A does not match the number of columns of B. But BA does, because B, if we go B times A, then the number of columns here is 2 and the number of rows here is 2, so we can do that. So again, let's do it. We're going to do first row, first column. That's going to give us the first element. So it's going to be 3 times 3 is 9. -4 times 2 is -8. So that's going to give us a 1. And then we're going to go to the next column. So that's going to be 3 times 5 is 15. -4 times +4 is -16. So we get -1. And then we're going to go to the last column. And so 3 times -1 is -3. -4 times -2 is 8. So that gives us a +5. And now we're done with that. Now we cycled through the columns here. So now we're going to go jump to the second row. And we're going to do the same thing. So we're going to start with the first column. And that's going to be -5 times 3 is -15. -3 times 2 is -6, and it gives us a -21. And then we're going to go to the second column. So second row, second column now. So -5 times 5 is -15. -3 times 4 is -12. So -15 plus a -12 is a -37. And then finally, we go the second row, third column, and that's going to give us -5 times -1, which is +5, and then -3 times -2 is 6, which gives us a +11. And so this is our product matrix. And so notice that AB is not equal to BA. So the commutative property does not work for multiplication of matrices. So it's not commutative. Okay. Okay, now we can also do this in the calculator by just using our matrix multiplication using the matrix menu. So we can do matrix A times matrix B, and voila, it'll give us the answer. Matrix B times matrix A, voila, it'll give us the answer. Okay, now be careful because if the rows and columns don't match up like they should, it'll give you an error. Okay, that's the end of this lecture. Make sure that you do the other examples in the textbook. Make sure you read the textbook. Make sure you understand what's going on. If you have any questions or something didn't make sense, go over it again. Take notes. Write down your questions so you can bring them to class. Do some of the exercises at the end of this section. Make sure you're able to do that. And then when we come to class, any questions you have, Ask them. We'll go through them. Anything you got stuck on, ask me. We'll go through it together. Until next time, have a great day. Bye-bye.